I'm going to start with basic rates of change. Now, I'm just going to explain the basic idea of this whole topic. If you see the dot on the top, say P with a dot on the top, that means we differentiate whatever P is. So whenever you see P with a dot on the top, just differentiate P, just like that. So differentiate P within in terms of T, okay? So this means that it is the rates of change of P over time. So T represents time. So over time, we want to find the rate of change of that particle P. Okay, and you get a better understanding of what I'm talking about here when we get to the questions, but just keep in mind that P dot means differentiate P. Now, when you see P double dot, it means differentiate again, so double differentiate P, just like you see over there, and again in terms of T, which represents time. So this is the rates of change of P dot over time. That is, it's going to be the rate at which the rate of change is changing. So this double dot tells us the rate of change in which the P dot is changing, whereas the P dot tells us the rate of change where P changes related to time. Okay, so just remember these two, and that's all you need for this first part. Okay, so I'll go through a little example, starting with example 1. If P is given by this expression, and you can see it's in terms of T, the time, find P dot and P double dot. All you need to do is follow these two instructions. P dot is simply differentiate P in terms of T. So you differentiate this one, so it's going to be 2T minus 10. I know you know all your differentiation very well, so I won't go through the differentiation, but all I did was differentiate P in terms of T. Now P double dot will simply be just differentiate again. So you're going to be differentiating P dot this time. Or you can think of it as double differentiating P. So if you differentiate this one more time, you simply get 2, which is the coefficient of T there. Okay, how simple is that? And that's all you need. Okay, so that was just a little example. And let's get right into the questions. Question 1. Okay, they give us what the expression is, and this is going to be x. So we're not going to have P this time, it's going to be x. So it's not always going to be P, it could be x, it could be y. Okay, that always represents the particle, the movement of the particle in terms of the time t. Okay, so I want to find x dot. When you see x dot, we simply differentiate this, and you get 3t squared plus 4t. Okay, very simple. Now B, this time it asks us to find x dot, which is the same as part A, but it tells us what t is. It says t equals to 1. So we want to find the rate of change of x at a given time 1. Okay, it could be 1 second, 1 minute, I don't know, but at time 1. So all you need to do is simply sub in your t equals to 1 into x dot. So just like that. So it's going to put 1 into all the t's and just calculate that to get 7. Okay, and that's it. So very simple again. Now C, x double dot. X double dot, double differentiate x. Or just differentiate x dot one more time. So it's going to be 6t squared plus 4, just your usual differentiation of that one. And then in part D, it asks us to find x double dot, which is the same as part C, but again, they tell you what t is. T equals to 1. So they want you to find the rate of change of that rate of change, and I want to find it when time equals to 1. So simply sub in your value of 1 into that t there, and just calculate it to get 10. Okay, so do you kind of get the idea there? So just double differentiate or differentiate, that's the whole idea. So that's question 1. Now question 2. Okay, this time we have another given expression for the particle x, depending on what the time is. But this time we've got some trigonometric functions involved, but we just treat it the same way as we do for any other expression. So again, I want to find dx over dt, simply just differentiate that, okay? And remember, differentiative sign is cos, so it's going to be 5 cos 3t times, remember the chain rule? You have to differentiate the input 3t again and multiply it, just using our chain rule. So you know that differentiate of 3t is 3, so simply it's going to be 15 cos 3t, okay? And B, we want to find the dx on dt, which is same as what we had in part A, but they give you what t is. Like in the previous question, they give you that t is pi. So all we need to do is simply sub in pi, or t equals to pi, into this expression that we just found in part A. So put pi into there, just like that. And remember guys, you know that 3 pi, you know a revolution of cos is 2 pi, isn't it? So I can just subtract 2 pi from there to simplify that to just cos pi, and it's exactly the same. Okay, so your outcome will exactly be the same, because I just used the revolution of cos, which is 2 pi. So you can subtract that from 3 pi to get pi, and you know that cos pi is just -1. You should all know this from your trigonometric functions and trigonometry that we've done, and multiply them together to get -15. Okay? And then C, okay, double differentiate. So but that means we're going to differentiate the dx on dt one more time. So differentiate this again. You're going to, differentiate this again. That's what it means here. And you know that differentiate of cos is negative sign. And then make sure you use the chain rule again to differentiate that input. So times by 3. And you should get -45 sine 3t. Okay? And D, okay, they want you to find the double differentiate of dx on dt, of x, basically, sorry. And they want you to find it when t equals to pi. So again, same procedure, sub in pi into t, which is over here, just like this. Okay? And you should know that 3 pi is pi plus 2 pi, isn't it? And you know that sine also has a revolution of 2 pi. So 3 pi minus 2 pi is pi. That's how I simplify that down. And you know that sine pi is 1, so multiply those together to just get -45. Okay, and that's it guys. So do you get the idea? It's very repetitive, isn't it? That was question 2. Question 3, find n when t equals to 2, and they give you a little property here. They say that n equals to 120 when t equals to 0. So they give you a little clue there, and they say that dn over dt, so they've differentiated n, which gives you 5 minus 3t squared. Okay, so this is the rate of change of n, which they already give you. So I want to find n. To find n, we have to integrate this, okay, because this is the differentiated form. So to get n, we have to integrate it. So just use your integration skills. You should get 5t minus t cubed. So I won't go through the integration. You should all know your integration very well. And make sure you always plus c. If you forget your plus c, you lose marks heavily. So make sure you don't forget that. And we need to find c though. We can't just leave it in terms of c. We have to find what that c is. So now I'm going to apply the clue that they give us. They tell us that n equals to 120 when t equals to 0. So sub this in. So sub in, well that's what they give us, so I'll sub that in. Sub in t equals to 0, and that's going to be 120. Okay? And then you can solve for c. c should become 120 because these are all zeros. So c is just 120. We found c, sub it back into here. So n is going to be 5t minus t cubed plus 120. Okay, so I'm just going to substitute t equals to 2 because they want you to find n when t equals to 2. So now that you've got n, just sub in 2 into all your t's like this. Calculate it, and you should get 122. And that's it guys, so n is 122, that's your final solution. Okay, so see how this question required a few steps. After you've integrated it, you must use your given property, okay, in the question. That was question 3. Question 4, find p when t equals to 0 if p equals to 10 when t equals to pi. So similar to the previous question, they give you a little hint or a little property that you may like to use it later, and they tell you that p dot equals to 8 sine 4t. So p dot is the rate of change of p, isn't it? So this means the differentiated form of p is this. So to find p, we must integrate it. Okay, and the integration should be very easy for you guys. Integrate of sine is positive cos, and make sure you do 8 divided by 4 to get 2. And then make sure you always plus c, like the previous question. Now, because we need to find c, what should we do? use the given property. So I'm going to, well, yes, simplify that. That just goes there. And then they give you the property, and we'll use that to find C. So sub in P equals to 10 and T equals to pi. Okay? And you should know that cos 4 pi is just 1. And then you do 2 times that plus C, and C should just be simplified to 8, just solving that for C. And then sub it back into your equation for P, so we sub in C back. And now we want to find P when T equals to 0. That's the question, isn't it? So sub in T equals to 0 into there. Well, they're very kind, they do very step by step. Sub in T equals to 0 into here, and that's what you should get. So I've subbed it in. You know that cos 0 is 1, so to calculate that you get 10. Okay? So it's actually very similar, or exactly the same process as question 3. Yes? And that concludes this part.